Okay, for problem number 3, we are given the transfer matrix H of S, and we need to find an irreducible realization in state space form, and we have to verify that it is a minimum realization. So we will have to check the controllability and observability after we get it. So I've just rewritten my H of S here, and we want to go ahead and factor this out. And so we will have 2 by 2 matrices over 1 over S plus 1 for the S plus 1, another for S plus 2 terms, S plus 3 terms, and then note we have a 1 here, so we will have, that will give us our D matrix. Okay, and just propagating things down here, the S plus 1 shows up as a 5 in the 1, 2 position, and a 2 in the 2, 1 position, zeros everywhere else. S2 is a 2 here and a 1 here, not there. S plus 3, the first column twice, and then finally the 1 is down in the 2, 2 position, zeros everywhere else. So this is our D. We've got that defined, and we'll leave that part off now as we do the rest of the factoring. All right. We'll take a note here that looking at our matrices for doing the factoring, what is the rank? The rank of the first matrix here, the S plus 1 term, is 2. Similarly, the S plus 2 term has a rank of 2. S plus 3 has a rank of 1 only. Okay, so our A matrix, adding up all the ranks here, we're going to have 2 plus 2 plus 1. So our A matrix is going to be a 5 by 5 for this one. Okay, so I've gone ahead and written out my factors. Since we have a 2 by 2, we're going to need 2 factors added together, or 2 sets of factors added together to get our S plus 1 block. Same thing for S plus 2 has a rank of 2, so we're going to need 2 terms of factors added together. S plus 3 only had rank 1, so it only needs 1 term. All right, and just factoring as we will, but let's go ahead and do the this 2 term first. So it's in the second row, but the first column. So first column 0, 2, and it's in the second row. So we'll put a 1 down here. So we'll just make our B's have the numbers, and we'll make the C's be zeros and ones. For the second term, then the 1 is on the top, and then it's in the second position. So we'll put the 5 goes in the second element. Similarly here, the 2 is on the top and in the first element, and the 1 is on the bottom in the second element. Okay, and for the S plus 3 term, we have, it's in the first element, the first column, and they're both 1, so 1, 1. Okay, so we've got it factored. Now we need to fill in our C and B matrices using this information. Let's see. Okay, so our C matrix, we're going to take the columns to build. And the B matrix, we're going to take the rows, and we'll just put them in an order. So let's just, since we don't have any higher order terms, we're not going to have any Jordan blocks with 1s. These are just going to be single Jordan blocks. So we can just fill them in and putting them in the same order. So let's do 2, 0, 0, 5, 2, 0, 0, 1, and a 1, 0 for B, taking all the rows in order. Same thing, taking the columns, 0, 1, 1, 0, 1, 0, 0, 1, and 1, 1 for the S plus 3 term. And so we've got our C and B matrices. I guess we should write our A matrix down. Let's just carve out a little space here. Our A matrix, as we said, it's going to be 5 by 5. First 2 are negative 1s. Okay, and then we have 2 negative 2s. And then we have our negative 3. Okay, so all these are zeros, a bunch of zeros. off of the anything that's not indicated as a number is a 0 then for 5 rows and 5 columns. And I guess we can remember then that our D also we had from before, D was 0, 0, 0, 1. Okay, now to check if it's a minimum realization, we need to look at the rows of B and rows of B for the controllability and the columns of C for the observability. So let's look at the rows of B first. Remember we have repeated eigenvalues first, so we need to check, are these two linearly independent? For this repeated eigenvalue, the last rows of B sub m, and yes they are. Same thing here, are these two rows linearly independent? Yes they are. And is the row with a distinct eigenvalue, is it not 0? Yes. So this, we have yeses to all of our questions that are needed for controllability, so yes, it is completely controllable. Okay, similarly for the columns of C, distinct eigenvalue not equal to 0, so we've got yes. And then we look at the first columns associated with a repeated eigenvalue. Are they linearly independent? Yes. Same thing here, these two rows for the -1 eigenvalue, are they linearly independent? And we have another yes. Okay, so we have yeses for all of our questions basically, and so yes, it is completely observable as well. And so that means it is the minimum realization. Minimum realization. Okay, so we've completed number 3.